Good. Good.
Beautiful. I'll give it probably another 30 seconds and then we'll kick things off. And Dr. Lee, you have your screen share capabilities. You're all good and ready to go?
Okay, may I start?
I'm going to introduce you. I just want to make sure that you have the screen share
Okay.
capability.
Okay, good though.
Awesome. Okay,
Mm.
then let's get this started. So, hello to everybody who's joining us live. Thank you so much for coming. This is a talk by Dr. Taerim Lee, who we're so excited to have join us today. And before we begin, I'd like to introduce Dr. Lee. In 2024, Dr. Taerim Lee received the CWS Societal Impact Award for her lifelong contributions to statistical education and public engagement. An honorary professor at Korea National Open University, she spent 38 years advancing biostatistics research and served as Dean of the College of Natural Sciences. Her work focuses on classification models and deep learning for cancer prognosis. She has held key leadership roles in national and international statistical societies and founded the Korean Women in Statistics Committee. She continues to promote science education as vice president of the Korea Association of Senior Scientists and Engineers. And we are so excited to have you with us today, and you can kick it off whenever you're ready.
Okay, let me start, So, good morning, everyone, and good afternoon and good evening, everyone, depending on where you are in the world. It is a great honor to be here today and to receive the Social Impact Award from CWS last year, 2024. I'm truly grateful for this recognition and even more so far the opportunity to share my research with such a distinguished international audience. In today's presentation, I will discuss how we apply a deep learning technique to dental data, and particularly in the context of oral health management and a prognostic modeling for hepatocellular carcinoma, HCC we call that. Over my 38 years journey in biostatistics, I've explored a range of classification and clustering methods, such as a CART, classification and regression tree by law, and a fast algorithm for classification tree, and a kernel discrimination and survival tree, support vector machine, and neural network. More recently, I'm focusing on deep learning approaches applied to the craniofacial data and oral squamous cell carcinoma and a hepatocellular carcinoma clinical and genomic data set together. Today, I like to introduce a deep learning framework that integrate HCC clinical lab data and genetic information, aiming to support HCC prognosis. I hope this talk sparks new idea and collaboration among us. Let me show the slide, Yeah. Mm. Mm. Yes. Yes, my topic is a biostatistical approach to prognosis modeling in dental caries and hepatocellular carcinoma. The outline is the background and motivation and deep learning model for dental caries and HCC, and finally remarks. So first motivation for me to develop the powerful modeling technique for exploring the functional form of covariate effects for prognosis of dental caries and HCC. Second motivation is to obtain the classification model for dental caries prognosis and HCC too. And third motivation is to extract new knowledge from managing dental caries and HCC using classification model, deep learning. The first purpose is to identify the effect of prognostic factors of this disease, and second purpose is to quantify the patient's characteristics that relate to the surveillance, dental caries management, and prognosis of HCC. Third purpose is to explore the functional form of the relationship of the covariate of dental caries and HCC. And finally, to extract new knowledge and set decision support the system is my final goal. But that motivation for me to fitting the deep learning approach. Nowadays, artificial intelligence is widely used across the oncology to improve the diagnosis and patient care, like here, post-operative rehabilitation and the virtual assistant, and also medical imaging diagnosis and drug development, etc. So our deep learning is combined artificial intelligence together for the training data set, and also neural network after that for fitting the progresses. Why the deep learning? The type for the deep learning is a structured data and unstructured data, for example, image and video and audio, etc. there. And finally, unstructured data analysis like here, and structured data analysis, first descriptive statistics and data visualization, and machine learning modeling method. There are many kinds of modeling here, and I try to the deep learning approach for this data, and predictive analysis like here. So research methodology, there are various kinds of here. So for me, the artificial intelligence and machine learning, especially in the deep learning there. So three data analytic model like here, descriptive analysis and predictive analysis and prescriptive analysis here. So also there is a very important data visualization, very simple structure for the structured data and unstructured data here, and the text mining here, and networking here. And nowadays, three-dimensional are very moving, and in moving visualization. So there is various kinds of developed for the data visualization here. I try to this kinds of visualization, but is under my ability in the future project there. So why the deep learning in the biostatistical research? Nowadays, the radio frequency identification increasing the use of sensing interface. It means that the various kinds of resources of data come from to our database. So it is a very typical big data here. So various kinds of mobile device here, and before these kinds of big data, we analyzed it separately. But after this concept of the big data analysis, we like here, we can shape more totally integrated image and stereoscopic understanding of the patients using integrated data management here. So finally we can get a better learning performance, and we can get a better results for the patient's treatment and prognosis and efficient treatment there. So the first data mining approach, I would like to the dental caries, high risk group and low risk group, divided two groups. It's a final response they are. So we can input the data, the preliminary linear regression and logistic and Cox model, and finally we can get a response variable Y. So, during this process, the algorithm is a decision tree and neural network, deep neural network. So we try to data mining approach like here. So deep learning, for the big data is good for the big data. So deep learning is a type of machine learning, as you know that. So machine learning is a class of algorithm that can automatically and concept through the automated analysis of large amount of big data. So deep learning is a special type of machine learning that learns by the discovering layer of increasingly abstract concept about the data and it's trained on. So deep learning is like here, you can recognize that input data, and we set the layer, hidden layer here, and we can get an output. So classify item and reconstruct the partial input and detect anomalies and search for the related item just they dreamed it. You know that it is a very simple the layout, but more deeper and deeper we can get from the big data we can get a big shape, a clear shape. So let me first start with a simple pixel, and we can get a regularity here, and we relate to the high level concept, and ultimately we can get a high level understanding of the original data automatically. So this deep learning algorithm discover this increasing abstract and embedded in the data automatically. So you can see this is input data, and there is a regularity here, and we can get some the high level concept. Finally, we can get a clear concept here. So that is a deep learning is a very attractive approach, I think. Various kinds of field deep learning applied, So these kinds of various kinds of field. There is an education and clinics, and the when I was 60 years birthday, I joined this class. So after that, I watching the wave in the sea. I pick up the right wave and stand by and wait for the right time and have the right tour. So there is various kinds of modeling methods. We can get a good concept and fitting the good data and a good modeling method, I think. So artificial intelligence is a very big, wide range, and machine learning is inside there, and the deep learning inside there. So it is a very attractive, and we can see the some very many fields application. We can get a very good information and very clear information there. So deep learning has a long and rich history. So when I was feeding the neural network, it spent much time. For one index, I get a 1 week computation. So when I move new office at the time, I all other things moved to the new office, but the computer stand alone for computing the 1 week, one index there. So, but after that, I gave up the neural network. But nowadays, applying the combining the deep learning and AI, there is a very good hardware and software make us easily apply the deep learning to the data there. So there is a history of deep learning. I skipped there, and various kinds of field they applied. The banking and insurance and healthcare and automobile and government. Especially insurances, we can detect wrong spending the money, spending the budget for the first insurance case. So in real data, they can get a very big money they can find by the deep learning approach. And also healthcare, we can have automatically identify the potential various kinds of MRI and CT and X-ray, various kinds of data we can get, and we can apply the deep learning to the healthcare. And also education too, learning analytics. That is a new method in the learning process. We apply the deep learning, and we can get a good learners process data. So that is a various kinds of field they apply. So input the data, and after we can get a feature space, and we can select and filtering the covariate. We can find these kinds of hidden layer resetting and output. Finally, decision making. We can have these kinds of results. And after these results, we can have a ROC curve and area under the curve. We can compare the according to the covariates, according to the layer set. We can get compare the efficiency, and that is a process of deep learning there. So we can have split the data, and for the training test, training data and test set data, and finally we can get a result here. So the process like here more complicate the inside the hidden layer according to the number of layer, and we can get another the output there we can have. So, this deep learning approach, fast and accurate view classification of the echocardiograms. That is the scattered input data and the deep learning model. We can find these kinds of very clear clustering. So what is the important covariate for the clustering, and what is the important covariate for the good treatment and long survival patients, So we can get a very important information from this process. So according to the covariate, we can get this kinds of ROC curve. It's a sensitivity 1 minus specificity is we can get this kinds of under the area. We can compare the efficiency of the covariate, and according to the this setting the in-layer model, according to different model, we can get these kinds of results. We can compare the efficiency of each model and each covariate too. So nowadays, why the deep learning we need that? It's a large data set, various kinds of structured and not structured data, and audio and video, something like that. It was a typical big data we can meet. So we have better hardware. It means they are very cheaper than before, so we can easily buy the hardware, and also smart algorithm. So advanced in algorithm make us to use these kinds of deep learning approach easily, I think. So there is a graph for the amount of data bigger and bigger, and the performance is deep learning is a big higher and higher. But all the classical learning algorithm cannot more improve, no more improve. Deep learning method good performance and with the bigger and bigger data. So simple neural network like here, but according to the hidden layer, we set different deep learning neural network here. So, input data here, and we filtering feature extraction. It means that we reduce the number of covariate, and we give a weight in the layer, and also we can simple output here, So deep learning approach like here, so doggy and cat input data, and there is an error here during the training process. And after that, we can get these kinds of exact results. In the equation like here, input data and weight, and we can activate a function, and finally we can get an output here. So it is a similar way, but the feature learning process by the AI, and also the neural network classification here. So classification method, there are many kinds of here, but all the method I tried too, but deep learning in this case is a good performance. There is a convolution and pooling and reactivated linear unit. This is a process of just before graph here. And it's a simple, and there is a number of layer. We can get a more different results we can have. So we can compare these kinds of the excluded variable of the processing, and more smaller number of covariate, more exact results, more exact sensitivity and specificity. We try to get that results. So we can allocate, for example, the liver cirrhosis 1 and 2. We can have a low data, train data, test data. We allocated this allocation for the training, and after that, the testing. Before the deep learning, I tried to tree structure the prognostic model for the HCC with the medical doctor here, and I can get a tree model. So child score and number of TAE and invasion and the size of the cancer and the AFP score is an important covariate. And finally, we can get life and death. So we can get a sensitivity and specificity. By this result, we can get the ROC curve too. And also the importance of covariate. There is a TAE number and AFP score and child score size is invasion and clip is the importance ranking. So it is very good information for the medical doctor. And also this is a survival tree. Final is a long-term survive and short-term survive, like here. So what is the important covariates and critical value for the long-term survive and short-term survive together? It is also good, important information for the clinic medical doctor to planning the treatment there. So I can get these kinds of various methods. So at the time, the random forest is the highest accuracy, and a deep neural network is similar but lower than before random forest. They are so sensitivity and specificity like here. So we can compare the various kinds of modeling method here, and we can get this kinds of output tree, classification tree there. So according to the covariate, we can get these kinds of mean left and right node, because one node divided by the two, or some model divided by 3 or 4, like there. So we can compare these kinds of mean. Then finally we can get a clear red group and blue group, like here. So that is a critical value, and also this is some the critical covariate here. So, and also we can get important plot in importance of a variable, like here. So random forest model with the liver cirrhosis, we can get an important importance of this variable. So we can compare the covariate, what is important for the patient's treatment. And also we according to the divided diagnosis 2, 3, 4, 5, and we allocated this kinds of train data and test data like here, so we can get a tree like here. And also the various kinds of method we can get a support vector machine is a very good performance. um, yeah, and the neural network I would like to, and the deep learning method like here. So we can compare choose the best method for this data. Fitting result like here, same result here, yeah, and here, and the specificity here. And according to this sensitivity and specificity, we can get a ROC curve, and the area under the curve we can calculate here. Let's see the same results here, and we can get a tree. So we machine learning method n by n matrix data input, and we can get this try to feeding, and it is a vehicle. We find our output here. So we can compare the machine learning method and deep learning method is according to you can see the what is the process difference. So we finally define the vehicle here, and the other results is wrong here. So but we can compare the this step is two step, but it's a one step we can get a result here. And also we can compare like here machine learning and deep learning here. Data set is very small, larger than the machine learning method. Big data, it will be a good data for this approach. And also the classifiers available. It's important covariate. There are many covariate was selected, but deep learning of fewer than the machine learning other method. And also training time, also the machine learning is short, but deep learning still long. But we can get a more exact, more efficient, we can fit the larger data. So that is advantage for the deep learning approach, I think. So you have the good hardware and lots of data, and then the deep learning method. So there is not a good hardware, and smaller than big data, then you can go to the machine learning method you can choose there. So as I mentioned before, that is we set the how many hidden layer, that is different results we can get. So we try and error various kinds of setting model. So we can express like this input data and this kinds of equation matrix form. Uh, that is a professional learning network. We're finding these kinds of visualization results too. Is a This one is the three-dimensional visualization of this modeling results. So deep learning, we can have a data like here. We can have these kinds of clustering. And after that, we have a more detailed clustering. And finally, we can get a clear how many interaction they have, and how many clustering we can have these kinds of results. So I think the deep learning is a very attractive method. So input data like here, dot, and we have an experience learning process. We can get this kinds of results we can have. So, so deep learning is analytic for better prognosis of medical data. And I explained the deep learning background, then deep learning analytics and efficiency comparison with other the machine learning method. So this Korean Oriental painting is teeth from the kids to the door knot and pick it up, and they child teeth pick it up by this method. So thank you for your attention. And also I have a Q&A, and before Q&A, I would like to a woman in statistics in Korean, the mentoring program like here, we have during COVID, we have a Zoom meeting, and also it's me here. And also we have a very workshop there for the students, a job seminar or the academic seminar too. Our ladies in Korea, we introduce, and a small group here. But the bigger, and every year we have various kinds of seminar and workshop. So it was activated, and for the after graduation, they go to the field. Is what kinds of potential and what kinds of ability they need. We invite the leader group in the company and the industry, and also the institute. A bigger group, we can have so many students interested in our activities. So we are very happy. And main function of our women in statistics in Korea, hosting regular academic session and job seminar and foregoing link, and constructing global network. And also another I want to introduce next year, we 2026 International Biometric Conference will be hosted by the Korea in Seoul. So it was Barcelona, I introduced the IBC. We prepared this fan, but just 2 months before COVID breakdown, our switch to the Zoom meeting and postponed to the 2026. So I invite this photo is the cultural experience. You can have this traditional Korean costume here and Korean musical instruments you can have. And also you can taste Korean food here. It is a map of the Korea wrapped one. And the right is typical the Korean food here you can enjoy. And in Seoul, that is a very convenient subway system like here. We prepared a one free coupon for you. You can use it 1 week and easily go to anywhere in Seoul. So, and welcome to the IBC 2026. Yeah, this is a video, short video for the Korean Seoul. Thank you. And that's all my presentation. Do you have any question to my deep learning approach for this data? It's okay for you? Yeah, moderator, actually.
Thank you, Dr. Lee. I was curious a little bit about the kinds of software that you find very useful for the deep learning.
Uh-huh.
Do you have recommendations about what is able to handle this amount of data?
Yes, I use the R programming. So if you want, I can give the source program for you. So nowadays, R programming, deep learning, R programming in the package, installed in the R, the programming there, software there. Yeah.
Great, thank you. And then I was curious to hear more about your experience with WISC and mentoring.
Uh-huh.
And from your perspective, what are some of the main topics that women especially find valuable for mentoring these days? What are some of the common questions or help that people are looking for when they come and experience mentoring with WISC?
Yeah, so every KSS meeting, we have a special session for the women's status in Korea. Our girl is so many audience there. 30% is men also, and also most of the academic the program there. Also the job guide. So after they graduate, they can go to the field, the industry, and the bank or pharmacy, and various kinds of. So we invite a leader, the woman statistician in the pharmacy company and also industry. They explain what the field in the field, what kinds of potential, what kinds of ability they need. So that is very important for the students just before graduation. So they prepared for the enter the company and enter the go abroad for the study by the uh, yeah, in every case, they need what kinds of subject, what kinds of ability they prepare. So it is very fruitful for them. Yes, main is two kinds of workshop and guidance for them. And also I mentioned before the our ladies in Seoul, you know. So the Eunkyung Lee in Ewha Women's University professor, very good doing in the R programming and the author of the some module in the R package. So she guided and initiated our ladies in Korea, and everyone, women statistician, very interested about that. Our ladies in Seoul.
That's
So
great. Thank you so much.
the
I had a question for you. First of all, thank you for such an incredible talk and for giving us a preview of all the work you do with WISC. Have there been other applications that you've seen that would be great candidates to kind of extend your research other than the dental caries and the cancer research?
So your voice is not so clear, you know, so a little sound, you know, would you speak more slowly and very near the mic or
Sure, I'll try one more time. If not, I'll go to the chat. I'm
uh,
so curious if you had any other applications in mind for the research you do other than in the dental and the cancer research application.
you know, I work in the Korean National Open University. So in the university's distance education university. So we are very important to that. It is a educational media delivery system, right? So all the students study by themselves. In my department master course, 30% 30%, 40% is medical doctor for the study of the bioinformatics, you know, data analysis there. So, you know, during the process by self-study, we analyze the students' learning process by the deep learning. We can get a learning analytics information from that kinds of application. So I mentioned before that bank and insurance and, you know, the educational field. They are very important hot issue these days in the educational media research field. So that is important another application to them, I think.
Thank you so much. Do we have any other questions from the audience? Ooh, we have one in the chat. I'll read that one out. What would be your next steps or future directions for this work?
For me, I retired 5 years ago already. So I learned the drum and singing in the chorus and a painting. So I don't have an idea deep learning applied to the painting. So nowadays in oil painting and acrylic painting too. So I enjoy the leisure time. No more deep learning, I think. But in the future, if I have any other medical data, the medical field, there are many doctor and dentists ask me consulting, you know, consulting to apply this kinds of new approach. So they don't have a detailed idea of this kinds of application. So I have many case consulting from that medical field still. So I guided for them and co-work together, you know. So that is our future work. But I enjoy my leisure time.
You.
Any
Do we
other
have
question?
any other questions? If not, then I'd like everybody to join me in thanking Dr. Lee for such an incredible presentation.
Yeah.
I'm going
Thank
to
you
stop the
very
recording
much.
now.
Thank
Thanks.
you. And so